proof of concept for ePBS would have to change. This is the hill that I want to die on. Until this is shipped, I'm not doing anything else. And I think this should be shipped.
If today you are, say, a centralized validator like Coinbase, that you have more power.
Hello and welcome to episode 136 of PEEPanEIP, the podcast where we dive into the latest developments of the proposal and EIPs that we find in the Ethereum ecosystem. I'm your host, Pooja Ranjan, and today we are focusing on a topic that's been generating a lot of discussion within the community. It's ePBS. EIP-7732, Enshrined Proposer-Builder Separation, was documented in June 2024. The proposal is currently in draft status, and as per the proposal, this EIP separates the Ethereum block in consensus and execution parts. Joining me to break this down into an expert level, I am inviting two ETH developers here who have been deeply involved in this discussion around ePBS, Potuz and Terence. Welcome to PEEPanEIP.
Hi.
Hello.
Thank you for having me.
In here today, we would hope to get an overview of PBS, ePBS, why ePBS, and anything that is related to ePBS, say for example, PTC. We will try to get to all these vocabularies and learn more about this proposal. But before we get there, may I request Potuz and Terence to share briefly about them, the journey with the Ethereum ecosystem, and what is the most passionate topic in the Ethereum ecosystem for you?
Oh, that's a hard one. Okay, I can start. So yeah, I'm Terence. I have been working on this space since as early as 2018. So yeah, so right now, majority of my focus is on EIP-7732. And then definitely I guess for me personally, this is basically what my passion is these days, is for this EIP. So yes, that's why I'm here. Yeah.
I can say something very similar. I am in this environment since 2020, I guess, by the end of 2020, just right before the Beacon chain launch. And I've been drifting from topic to topic, but since the last 1.5 years to 2 years, I've been only working on this essentially. And this is the hill that I want to die on. Until this is shipped, I'm not doing anything else. And I think this should be shipped.
Thank you both for sharing that. And that brings us to the fact that we may perhaps have some more questions for you, like why do we want to ship it and when do we want to ship it? We'll get in there. And I'm sure anyone who have been following this topic must have been following our guest on Twitter for the breakout room and the summary that is regularly being shared. But in any case, for all our listeners, you can find Twitter handle of guests on description section of this episode. Moving forward, I understand there is a presentation to be shared. So without further ado, let's peep in.
Yeah, so let's get started. So this is EIP-7732. So the title is Enshrined Proposer-Builder Separation. And then this is the EIP itself. This is the link. So feel free to check out the link. The EIP is by Francesco Dell'Amoto, Bernabe, Michael, Potuz, and myself. So it's worth noting this was the very first EIP that adds a mechanism for consensus proposer to choose the execution proposer. So it's the first of its kind for this type of organization market. So it's cool because it separates Ethereum block from consensus and execution, and which we'll get more into. So I want to start with the first few disclaimers. So this is not like a talk about MEV in general. MEV is a very spicy and yet controversial topic and stuff, but this talk is not so much about that. And this is also not talk about why we should do EIP 7732. I am not gonna try to sell it to you. I will tell you why technically it makes sense to do it and what are the changes that you have to make based on the current consensus spec. So this talk is aiming more for client implementers or community hobbyists that want to get more into the details, basically. Say if you want to implement it, where would you start? What are the high level things? I think towards the end, maybe we can talk more about the why, but my slides don't really cover the why. But if you want to learn the why, you can also look at the EIPs. Like the EIP is pretty concise. The first, I believe the second section or the third section covers the rationale pretty well. Okay, so let's get to the key changes. So what are the key changes? The first key change as currently spec is that the builder itself is a validator. So to participate, to be a builder, you have to have a balance in the protocol. And if you have a balance in the protocol, the easiest thing for you to do is basically to participate as a validator. So that's the first key change. The second key change is that we add a new community that's called Payload Timeless Community, which I'll get more into. And this community perform a duty that is payload timeless attesters. Okay. And then another key change is that the beacon block body now includes the header instead of the payload. So if you look to the right, the first timeline is what we have today. The second timeline is what basically we're changing it to, right? So today, a consensus block includes the execution payload, but in EIP-7732, the consensus block just includes the header itself, which is very similar if you understand MAV boost. It's basically what you submit to the relayer. You have this notion of a blind block. The blind block just contains this header, which is a transaction root, not the actual transactions. And then another key change is that a slot is divided into 4 intervals instead of 3 today, okay? So today you have your beacon attestation at the 4-second mark, and then the aggregated attestations at the 4-second mark, right? But in ePBS, we have 4 intervals. So the beacon attestation is at 3-second, aggregated attestation and attestation payload reveal is at 6-second, and PTC attestations is at 9-second. So when you first look at this, you'll probably like be slightly worried that, oh, are we gonna have enough time? Are we shortening the slot duration? Is this like bad for the protocol? What are the downside, right? So I think like personally, I'm not too worried for several reasons. The first reason is that consensus block is relatively fast to process. As we learned from the pre-merge days, processing a consensus block should take less than 100 milliseconds. What is heavy is this execution payload that's heavy to process, right? So now you have 3 seconds to process a consensus block, which in my opinion should be more enough. And then the second thing is that now your execution payload is pipelined. That is revealed at the 6-second mark. And then it turns out that you have at least 9 seconds to process the execution payload versus the 4 seconds today, but much less because people play timing game. So because of this like pipeline approach, we were able to essentially squeeze more into the slot. We also don't have to prolong the slot duration from 12 seconds to 16 seconds like the original proposal. And that is also very nice. This is a very desired property. Another key change is that one that I think we haven't gotten used to because of today, a slot is either full or skipped, right? But in this new paradigm, a slot to be full, skipped, or empty. So empty here just means that you have a consensus block, but you don't have the execution payload. So meaning the builder just did not reveal it, or the builder revealed an invalid execution payload, or the builder revealed late, right? So then you could like, so today, let's go through this again. So today, this is the full block, everything's happy. And then you have a skip block. A skip block just looks like this. Your consensus block is missing. Because of that, you don't have your execution payload as well because the first proposal is missing. And then you also don't have PTC attestations, right? But then you could also have a case that we don't know, we haven't seen today is this execution payload is just missing directly, right? And then we call this like an empty block. But what is nice is that even though the execution is missing, you still have the consensus information intact, right? And today, basically, if the execution payload is invalid, then the consensus block is invalid, then the whole thing goes missing. But for this, you kind of decoupled the validity of execution payload with the consensus block. And that's one improvement. And then, so let's see. Yeah, and I talked about pipelining. Pipelining here means that both consensus and execution are processed at a different stage of a slot versus they all process together. So basically, you don't have this hot path. So today, what realistically happening is that everything like arrive here, then you have like 1 second to process everything, right? This is your hot path, your CPU hot path. But now it will look more something like this. So you play timing game, the block arrives here, but this is fast to process, and then your payload is revealed here, and then you have a lot more time to essentially process the payload. This will allow you to increase the gas limit, assuming the state growth is solved, and do all the cool things. So here are the spec changes. I won't go so much. I mean, there's not much to talk about this, basically slides, basically, right? So currently the spec is in the EIP-7732 subfolder in the consensus spec. So just like every single EIP, every single hard fork, right? You have your beacon chain, you have your for choice, you have your P2P, you have your honest validator. And depends on what software components that you're interested in writing, you look at those spec, right? And it's worth mentioning that like another nice thing about this EIP as currently written is that there's zero change on the consensus layer. You don't have to worry about that. And there's zero change for the engine API as currently stated. Okay, so I want to go through some like beacon chain changes, so containers. So let's maybe look at this diagram that I drew here, okay? So this is a very hand-wavy diagram, but I hope I'm able to illustrate the ideas. So here are your P2P subnetworks. So the P2P subnetworks, as the objects arrive, it goes through this P2P verifier and forwarder. So this implements the P2P spec, basically. You look at this object, you check if it's valid or invalid. If it's invalid, then you will down score your peer. If it's valid, then you will forward the message back to the P2P network to your peers, and then import it depends on what's the downstream usage of, right? Then you have your state transition function. This is a peer function. You have your pre-state, the block, and the post-state. And then you have your Fortress engine. The Fortress engine implements the Fortress spec, which calculates what is the head of the chain. And then you have your honest validator duty here. So validator duty basically tells you like how to sign for the block, right? And then you have your builder zero execution client. So the beacon chain changes here are essentially what's in the state transition function. So we added some new containers, such as like payload attestation. So payload attestation is this new object for ETC committee. So its only thing is to vote honestly whether it has seen an execution payload and what is the execution payload. So execution payload could be full, meaning that the builders reveal the execution, or execution payload could have this withheld status, meaning that the builder is not so confident because the proposer revealed the block very late, it's not getting enough votes. But in this case, the builder has the choice to say that, okay, well, I don't want to reveal my payload because I know this block is going to get reworked. So therefore, I'm going to give this withheld status, and then withheld will give additional for choice weight to the parent block. And this will enable the next slot proposer to rework essentially this late block. So payload attestations has two forms. The first form is just this single message, which is signed by the PTC member. The second form is this aggregated message, but this aggregated message is not broadcast. It's basically done by the proposer for the next slot. So the proposer for the next slot, this consensus block, will include this aggregated message. And then doing this is just for reward and accounting, basically. You want to reward the PTC members for doing their things correctly. And then, so there are other two objects. The first object is this header. And then this header becomes a consensus object. And then the second object is this signed execution payload envelope, which includes the builder index, the builder signature, and then basically the KCG commitment root and stuff like that. And then we also updated beacon state by adding a few more fields. most importantly, the beacon state will track whether the previous slot is basically full or empty. This allows usage for the for-choice store. This allows usage for other things. And then we also added withdrawals root. So because in ePBS, the withdrawal today is essentially deterministically generated by the beacon state at the given slot, but the withdrawal is actually redeemed on the execution layer. So we basically need a way to cache the withdrawal, the root at the state when you process the consensus block. But then at the execution state, you want to make sure the withdrawals that getting from the payload matches the withdrawal from the state itself. So this is why we caches the withdrawal root. And then, yeah, so those are the beacon state changes. Okay, another thing that's worth mentioning is that now the state transition function are sort of divided into two parts. The first part is that you have your state transition for the consensus block. That's everything that happens in the consensus. And then you have a post state and the state root of that. And then the second part that is new is that now at the 6-second phase, you have execution payload. And now you process the execution payload. And now you have this new state and basically post state root, right? So there are kind of two phases now. And then it's worth noting that there are things like Electra things to be specific, like deposit, withdrawal, consolidation, request today. Those happens on the more so on the execution side. So those are moved to the execution reveal phase, basically, right? And then other than that, it's basically, yeah. And then we added this new process payload attestation function, essentially, to reward PTC members for the correct votes. So here are the changes. Yeah, so those are the changes for the state transition function. Okay, so then the next thing to talk about is new validator duty. So the first new validator duty is for validator client to participate in payload timeless committee. So similar to beacon attesters so I guess take a step back. PTC is borrowed from beacon attesters today. So it's sampled through the beacon attester committee. So I guess you borrow the first few indexes from the beacon attesters committee. And then if you're in the PTC duty, you don't have to perform beacon chain attestation duty. And then we only borrow 5 of them, so it's not that many. It's fine. So how do you know you're basically like proposing for PTC? So you have this like get PTC helpers from the spec. So you look at the spec, you implement this, you see if you're a PTC committee member. So if you are a PTC committee member, then you do a few things, right? You first see if the current consensus block has been released, whether you have it. If you don't have it, then basically, if you don't have it, then you don't have to do anything, right? And that's nice. But then if you have it, then you look at how this payload, execution payload is essentially like whether you have seen it or not. If you haven't seen it, then it's easy. You just vote for absent. And then if you have seen it, then you basically just vote for the status, right? If today it's withheld, then you vote withheld. If it's not withheld, then you vote present. Then you sign the vote, and then you gossip the payload attestations to the subnet. And then here are the validator changes if you are a solo proposer. So if you're a solo proposer here, you don't care about what the builders are doing. You don't care about bids coming from the P2P. So what you have to do things like slightly more extra here, because you actually need to sign the header. This is the additional step. So how you would do is that like you would essentially get a payload from the execution client, you convert the payload into the header format, you sign the header, you put in the consensus block, you gossip out, and then in parallel, because you trust yourself, you can just sign the execution payload and then gossip out. And then blob sidecars as well, you can do that, right? So this is basically what you would do as a solo proposer. But then as a proposer that's using builders that you're rational, you want to choose the best bid. Or you wanna use your local block, for example, if today the censorship oracle flag is set, or because a local block has a higher value after you do this local boost thing, then you consider your bids or headers from three resources, right? You consider from local EL, you consider whether the headers from P2P, and then you consider the headers from the builders itself. So today with MEV Boost, you essentially query the headers or the bids through all the relayers, and then MEV Boost will return you the best bids, right? But here it's very similar. You have this curated list of builders, and then you essentially get the bids from every single one of them. And after that, you choose which bid you want, and then you include the bid into your block, and then you gossip it. So here are the P2P network changes. So basically here, as a P2P, essentially you added, you added actually three more gossip verifier or gossip network to subscribe to. The first one is the header itself. The second one is the payload when it reveals. And then the third one is the payload attestation message. So again, so the job is simple. You verify it. If it's correct, you forward it, you import it. If it's incorrect, you reject it, and then you don't score it. Depends on whether the message itself is invalid or it's old or something like that. On top of that, there is this new RPC request for syncing execution payload. This could be by root or by range. So this is just basically when you want to sync to the head of the chain, or you realize that I have a consensus block and then it's supposed to be full, but I don't have the execution payload to go with it. But I want to sync to it, but I only care about this one particular execution payload that's missing. So you can request that by the root itself. And let's see. Okay, so the next one, the 4 choice changes. So I don't think I will be I don't think I will be able to explain this very succinctly, given the time we have or given the slides. So I would highly recommend, if you're interested in 4 choice changes, review the 4 choice annotated spec and then the ePBS design spec that Potuz wrote. Those all have very good 4 choice sections. But then the TLDR is that because we want to guarantee builders withhold safety and builder review safety, we also don't want to compromise the current proposal safety. The best midpoint is that by adjusting this type of boost values. So proposal boost changes from 40 to 20%. On top of that, we have this payload withhold boost, and payload review boost. And then the 4 choice is probably the most complicated part of this whole ePBS thing. So because of we are considered today, it's basically a very simple block voting scheme. But in ePBS, it becomes 3-dimensional. You have your block, you have your slot, you have your review status, right? So ePBS is worth mentioning that we're actually adding block slot voting, meaning that if you have a block, and then if attestations is voting for its parent, the vote of such attestation is actually counting against that block itself. Today, if you're voting the parent, then the attestation is supportive, but in this case, we're counting against it. And then the 4 choice store has additional fields. Again, this is how the spec is defined, but client implementations may be very different because different clients have different 4 choice algorithm that's a lot more efficient. So first is that you need to store the execution payload state. That's the first thing you need to do, because the execution state and then the post state of this execution and then the post state of this consensus block is basically 2 different things now. And then you have to track your PTC votes from the attesters. So the PTC votes will be able to tell you at what block, at what slot, whether the block is full or empty. And then you also need to track whether a payload's withhold boost root and then the payload reveal boost root. And then the 4 choice handler also changes as well. And then, for example, here's the on block, and then the on payload attestation message, and the on execution payload. I don't think it's worth going that into detail, but if you read the 4 choice spec, you notice those are the changes basically. It's worth noting that the blob data availability today is checked at the beacon attestation phase because it's revealed the same time as consensus block. But then for ePBS, the blob data availability is basically checked on attestation payload, which is pipelined into the second phase. So you allow more time for the blob to propagate. And that is also a very nice property that we gain from ePBS. Okay, and then I guess the very last slide that's worth mentioning is that how get new head works. So today, to get a new head is fairly simple. You start with a justified checkpoint, and then you go through all the children, and then you find the children with the highest weight, and then you repeat the same step again. So you have this kind of recursive algorithm that's always looking for the children with the highest weight, right? But then in ePBS, it's slightly more complicated because of you have this reveal status, and then you have your block slot voting, right? So in a case, so your children is actually the children that have to match the parent reveal status. And then you also add in yourself as a children, because with block slot voting as well, that like basically like the head doesn't need to be the tip of the chain. That the head could be the parent of the tip of the chain because of how we do block slot voting. Again, this is probably one area that like we probably require the most eyes on, just because of like for choice is pretty complicated today already. But with ePBS, for choice becomes a lot more complicated. Here are some miscellaneous items that it's probably worth mentioning that I didn't cover on the slide. The first one is that as a tester, if you're in the P2P community, we can skip attestation duty. And then the second thing that we need to do is that we probably need to accommodate the builder, because if you're a builder, you need to decide whether, like, if I want to review this payload with the withhold status, or I want to review the payload fully. And then my decision of such depends on how strong this consensus block is. If this consensus block, say, is reviewed here, and then the attester is already voting for the previous block, and this consensus block is very, very weak, right? And in this case, if I'm a builder, I know this block will likely get reworked anyway. I don't want to reveal my execution payload. So in this case, I would reveal my withhold status. So I probably will need like a beacon API to get the weight of this consensus block. I don't believe we have something like this today. So we probably want to think about like what beacon API we want, whether this is like a streaming endpoint or it's just like a direct get endpoint. Another thing that is cool is that with ePBS, you can add like builder-based circuit breaker. So today the circuit breaker is very like janky. Essentially, you look at how many slots are missed in the previous epoch. You look at how many consecutive slots are missed, and then you choose to use basically local block or not, right? Because today, I believe to sign the bid, it's actually not the builder that's signing it, it's actually the relayer. So it gets really weird. So you cannot really implement like circuit breaker nicely. But with ePBS, you actually can, because this header contains the builder's public key, which is registered on-chain. You know those information. So if today I see this builder essentially reveal an invalid payload or reveal payload super late, I can implement the circuit breaker saying that, okay, in the next slot, if I see a header from such builder, I will just ignore it. So we can do something like that. And then there are probably builder API changes, but then again, I don't want to get so much into builder API here because it's kind of out of the protocol. And then it's worth mentioning there are compatible designs out there, right? And then, for example, slot option. It's not difficult to add slot option to basically EIP-7732. There are good reasons to add slot option, which I won't get into. And then it's also easier than before to add inclusion list to ePBS as well because of the block slot voting. And then for PEERDUS, because of you get extra time to propagate blobs, for PEERDUS, it's probably, there's more good reason to add more blob sidecars basically, because now we're not constrained by this like 1 second that's essentially here, right? Okay, so here is what you can do to participate. There are multiple avenues. If today you are someone that want to implement for other clients, someone that have feedback on the spec in general, you can R&D Discord, there's ePBS channel. I mean, everyone's very active there. There's bi-weekly ePBS breakout call hosted by Potuz. You can also join that call. It's open, the link is literally on the GitHub, so you can join. You can review the consensus spec. And then Barnaby from Ethereum Foundation also have this very nice open questions tracker on EIP-7732. It's worth to kind of show them for 5 minutes. Basically, here are all the open questions that ePBS have seen so far or are open for discussion. So yeah, if you're interested, take a look at this, click one of the link, and then if you have good solutions or feedback, just drop them on Discord. So yeah, this is basically what I have. I guess we have another 20 minutes. We can leave that to open questions, or Potuz can add anything that I missed, and yeah, go for it.
Wonderful. Thank you so much for this great presentation. And I think the presentation has already answered many of them. Those were on my list. I really love the presentation that you did. It definitely will help in understanding proposal in an easy way to the broader community. You explained about changes that it brings, the core concept of 7732 in layman's term, and you also touched on PTC, which I was hoping to understand. So thank you for that. Touching on state transition and new validators duty would also encourage to new validators, not the new validators getting into the system for the first time, but validators in general to learn about their new duties. I sincerely appreciate all of these. And I would love to add all these additional resources that you have shared in your presentation in the description section for people to follow. For participants on the call, if you guys have any question, please feel free to drop it in the chat. In the meantime, we can perhaps take a few other questions which we have already collected. So my first question here is, we talked about ePBS, but before ePBS, there was PBS. So can you briefly explain why PBS was originally proposed and how ePBS is maybe similar or different from the PBS?
I am pretty weak in this whole MEV discussion, but my understanding was how PBS was proposed is that people kind of have some sort of narrative and story, and one of the story was that if today you are, say, a centralized validator like Coinbase, that you have essentially more power in terms of it's tracking MEV, then essentially you have this type of private sources, then your validator's APY will be higher, then more people will just use Coinbase for their validator, then you have this very centralized vector, right? So what PBES, I guess what it means originally is that to democratize this builder role such that anyone can essentially use the builder. I don't think, honestly, now looking back, personally, I don't think this was the right approach. I'm just gonna say that. But then I guess this is what PBS means. But then ePBS just means that, okay, well, today we already have this PBS. Let's enshrine into the protocol such that proposer and the builder can essentially, without trusting this third-party relayer, to do this fair exchange. And then on the positive side, you also get pipelining, and that is also very nice. I'm sure Potuz has probably more to say. Yeah.
So, I mean, there's many reasons why PBS was adopted, and PBS actually predates any discussions about MEV in itself. There are many attributions that a validator does today that were designed pre the Beacon chain, and then they were enlarged at the merge, that are all given to the same entity. And these duties reflect different tasks for which different resources might be needed. To be more precise, a validator today attests for what the head of the chain is. So it decides on consensus, but it also sequences transactions in the blockchain. And these are completely different attributions. There's no need why these two things should be the same. It might also check for censorship in the future. It might also help with censorship in the future by having inclusion lists and these things. But this, and again, this attribution might be the same leader that we have today, the proposer, or might not. There's sync committee attributions to help clients running on a phone to see trustlessly what the head of the chain is. So the point is that all of these different attributions that validators currently have that oftentimes are included and decided by a single entity, which is the proposer at every given slot, might actually be carried out by different actors. And these actors, therefore, we can require them to have different resources. So that's the first thing. So this is more like the general concept of ePBS, for example, or other concepts that are around that came even before the merge. Now, what happens? In the roadmap, one of the things that we expect, and this is nothing to do with MEV or not, is that the hardware requirements to produce a full block with all of the proofs that we need once we go stateless, it's going to be very hard to keep this currently hard requirement that we have, that validators should be able to run on a Raspberry Pi or on a very cheap consumer hardware. Once we move into such a system, then we naturally would need someone to produce these blocks, to produce this resource-heavy part of a block that the normal validator would not. We want to keep consensus being decentralized and not whitelisted as well. So under these circumstances, this idea came. I don't remember the first person to mention this, but certainly one of the first ones mentioning these separations was Justin Drake, who suggested that we could, in principle, allow the sequencing part or the proof writing part when we move to danksharding to be carried out by someone that actually has more resources to do this. And then PBS was born because of this. But now in real life, after the merge, we see that already this was happening. Even before the merge, miners would offload block building to builders or to searchers themselves that would provide them bundles. And this is because, well, different players in the environment do have different resources, and not only hardware resources, but data resources. Certain players have transactions that never make it into the mempool, never make it into the public mempool, and those transactions need to be included. That's why certain players have the ability of producing blocks that are more profitable. If we didn't have something like PBS, then the auction to make these transactions or these bundles to be on chain would be in detriment of our users. We will go back to gas auctions like we did have before flashbots came in. Our users would be faced with a lot of transactions that are reverting and pay more just to use the chain. So PBS in some sense solves that problem. And the problem that it causes is that we do not know how to do PBS in a completely trustless manner today without enshrining some parts in the protocol. And this is what ePBS tries to solve, the trusted part of the auction itself.
Wonderful. Thank you so much for this explanation. I mean, I would hope with the reasons to put it on the mainnet, could we just consider ePBS as an extension of PBS research and 7732, maybe the documentation of specs to be implemented on the Ethereum mainnet?
Right. So the specifications are there in the EIP. They are essentially complete. We are going to make changes as other clients start implementing. We're going to find mistakes. We did find already a few minor bugs on the specification, but that's common on any EIP. As soon as clients start implementing, we need to hash out a bunch of small bugs. As to why this should go on mainnet, well, there's a rationale section on the EIP that's, I think, quite clear. It's funny enough that perhaps the main reason to put this quickly on mainnet has nothing to do with the main problem that ePBS solves. Even if we didn't have the ePBS part of it, like removing the trusted assumption of the auction, what ePBS brings us is something that is a big gain, in that validators currently have very short time to validate the full block. Terence explained this in the technical aspects, but I just wanted to repeat that punchline that he had, which is currently a validator receives a block and it has a very short time. typically in average is about 1.5 seconds to 2 seconds to validate the full execution and consensus part of the block and then submit an attestations for that block. What ePBS does, it removes completely the execution part of the validation. So it removes this from the hot path, and validators would have the same time, let's say 1 second to 2 seconds, but to validate only the consensus part of the block, which currently goes around 100 milliseconds. It takes around 100 milliseconds to validate. So that's a huge advantage in that it allows us to actually scale L1, because we'll be able to submit larger blocks. At least if we solve the disk bottleneck, the CPU bottleneck will never be there, because we'll have like a very large time for the consensus part of the network to validate the execution part. And so that's a huge chain, a huge win that can be done in many different ways. But the beauty of the current proposal for ePBS is that it achieves this delayed execution validation without ever changing the consensus side of the execution engine. So the execution clients don't need to write a single line of code, and they get for free this delayed execution validation. So that, I think, is perhaps the main reason to include this quickly. I personally believe that the reason for this to be on mainnet is the fact that we currently have over 92% of our blocks are delivered by 3 trusted entities. And this is an acceptable network that wants to call us trustless and censor-free. Yes, we currently seem to have improved quite a bit into the censorship aspects of the network, but it is still because we are trusting 2 or 3 players to not censor. This is something that needs to be solved, and I think this is a solution that is implementable right now. This is not just an idea in the air. This is a solution that is completely fully specified, and clients are already working into having a prototype soon.
Pretty interesting. Thank you for sharing. I see you have been an advocate for this proposal, and I see why you have been advocating. That's really good to know that we have many reasons, especially one of the core features, that's trustlessness that we talk about being in the blockchain ecosystem. Well, my next question is a little bit related to technical challenges that may have been there. So touching on the complexities of this proposal and how they can be overcome, there was this mention of a document by Barnaby listing all these open questions. Would you like to maybe mention 1 or 2 technical challenges or open questions that may lead to the spec change, and where are we on that?
There's Barnaby opened a Notion document. Perhaps I'll if it wasn't there, I'll put it on the chat, and Terence is already linking it in the video, with some discussions that might be blockers, some problems that are currently there. We have seen, so there are some interactions with inclusion list designs. There's some interactions with different auction types. So if I have to pick a couple of problems that we see today, I would say that a big one is the discussion of whether or not in the auction we will commit to a particular block, a particular payload or not. So this is the difference with what people call block auctions versus slot auctions. In block auctions, the proposer sends a consensus block with a commitment to a particular payload that was already produced by the builder but has not been revealed yet, and the builder promises to reveal that payload later. In slot auctions, the proposer just commits to a particular builder. It doesn't commit to any block at all. It just commits the builder. This builder will reveal a block a few seconds from now, and the builder can reveal any payload after a few seconds. So now there are trade-offs, both on the economic side, like the kind of things that Rig would study. There's not much trade-off on the engineering part of this. These 2 changes are essentially the same. So committing to a payload or not doesn't really change much for the client implementations. But there are some trade-offs into the data availability side. There are trade-offs in the timing gains that can happen. There are trade-offs in how these 2 auctions interact with inclusion lists and how they enable some or not. Well, those are questions that are being actively investigated at the moment. So if you're interested in this, that's the difference between one or the other one. I think it's an important area of design. which I'm not sure if fortunately or unfortunately, so far I get the impression that the only people that have been looking into these two designs were mostly focused on economical differences on the auction instead of like other things that can happen, like the engineering problems. So it'd be nice to get a point of view of people that are not directly involved in the EIP process currently, or are not directly involved in the economic aspects of such auctions.
Thank you for sharing that. I hope this document may attract attention of any other new contributor as well, who maybe add their thoughts, feedback, and may be able to support client development team on questions those have been highlighted there. My next question is with respect to community feedback and in general, the response. As we all know, like whenever a proposal is proposed for Ethereum ecosystem, we try to collect community feedback. That's also an integral part of the EIP process. We have a dedicated FEM page for each of these proposals, and so we have it for 7732 as well. Given this proposal is fairly new, I don't see tons of comments over there. But with the breakout room meetings and other places where we receive feedbacks and comments about this particular proposal, how would you say that Ethereum community has responded for EIP 7732 so far?
I actually thought EIP-7732 consider like Petra is really full. You cannot get into Petra. It's a very it's more forward-looking EIP. Consider it's a forward-looking EIP. I think the sentiment I'm getting is that we actually get a lot more enthusiasm from previously what I've been seeing, right? Like right now, I believe 4 out of the 5 clients have been started implementing it. And which is previously, I don't believe I have seen an EIP that's like that. So I would say besides the builder, I think from the client implementer and the researchers, I think the feedback is very good. I wish there's more feedback from the builder's perspective, what do they need in terms of the Beacon API, what type of endpoint they need, and stuff like that. So I would say we're liking builder feedback.
So I wanted to add something to that question. It's the Ethereum community is pretty much heterogeneous, and it's very hard to get feedback on a particular project. Say, for example, you want to make an EVM change, then you have a whole community of developers on the application layer that will be impacted by this, and then you start getting feedback from them. This particular change does not really affect users in any form. So it's hard to see users reacting, neither pro or against. It does affect validators. Validators are typically in favor, like the whole ETH staker community is in favor of such a thing because they're going to have guarantees that they can contact the builder directly. They, in principle, should get better auction results. So it's an economic incentive for proposers, for home stakers, and for validation pools. Builders, there aren't that many, so it's very hard to get an opinion of them. There aren't that many builders today. It's not really clear how many new builders would appear because of this. I know of at least a couple. And the searching side is an interesting area because I would expect that searchers would actually change the dynamics a little bit under ePBS. And I've been trying to actually reach out to searchers to see what they think about this. And I haven't really gotten neither a pro or against feedback from them. I think at this stage it's early enough that they don't consider this as something that will be, which is, we should assume that people are skeptical of any EIP that's going to make it on mainnet because most of them don't, or most of them they get delayed by several years. So I would take the skepticism of people, and they will start seeing more opinionated discussions when this actually gets some more traction on the core developer side on ICD. All I can say is that every core developer that I've talked to, except a few, except like a couple of them, every core developer that I've talked to is strongly in favor of having such a change. The EL devs are very happy with the delayed execution, and the CL devs, at least many of them are aligned, which in that this is a problem that we need to have a solution, and that this seems to be a solution.
That's good. And I think perhaps this can be a call to action for listeners that if you know someone or if you are the one who may be interested in adding feedbacks on builder and searcher part, please head off to a Fellowship of Ethereum Magician page and start adding your comments, thoughts, and feedback. Help developers shape up the proposal and make it ready for the upgrade the way you would want to see it on the mainnet. I think you have already answered my next question over here in the chat. So I was generally wondering how many clients have already implemented. It seems like it will not be an area of focus for execution clients because there are no major changes, but on consensus side, have we seen implementation by most of the clients?
There are 0 complete implementations. Prism is the one that is most advanced, and it's still a few weeks away from like starting even an interop. But every single client told me that they have already code in place, except Rangine on the CL side. I've gotten a confirmation from Lighthouse, that was the last one lagging, that they started. So it seems that this is something that even if it goes slow, it has manpower allocated on every major client today on mainnet. So yes, so that's on the CL side. Perhaps a caveat, and it's an important caveat, is that if this change goes with inclusion lists, then inclusion lists interacts deeply with ePBS. So if this change is decided that it's going to be shipped together with an inclusion list proposal, every proof of concept for ePBS would have to change, would have to actually change, and it would have to involve the execution side as well, not only consensus clients.
Adding IL to ePBS will definitely make it a heavy upgrade whenever it comes to. All right. I have seen that 7732 has generally received great support by developers community, and you are already endorsing that, suggesting that client teams are allocating resources for the implementation. Do you think of any challenge, if there is any, for 7732 to be accepted for an upgrade? And if so, what that could be? Because we have seen that inclusion list was also considered for Petra, but ultimately it is not there.
Yes, definitely. It is a contentious upgrade. There are, as any change in which there are economical actors that are being influenced, there will be parties that would lose some power and parties that would just gain some power. And as in any such update, there's going to be a lot of politics involved. I tend to not care much about this. We were trying to have a complete specification and the technical side of it completely solved, hoping that the community would just take this as it is, as a solution to a problem, and hoping that the politics would solve by itself. Now, the inclusion list proposal that you mentioned that was considered and ultimately was left out, that was a different kind of challenge. There wasn't an actual political challenge into getting inclusion list in or out. What happened with the inclusion list proposal, which is 7547, what happened there is that shortly before we were closing on what EIP should be included in a fork, we found that the interactions of 7547 with account abstractions made it much, much more difficult to implement, and it was a new problem. It opened a completely new area of problems and design and bugs that could happen on such an EIP, in that some of us felt uneasy proposing such a change that we hadn't, with all these problems that we hadn't even thought about and we just discovered. Now, of course, as with any EIP, these kind of things can happen, and it can happen on ePBS. I mentioned one problem that we just thought about not long ago on block auction. Can give a little bit more of detail, but one of the problems is that on a block auction, the builder might actually want to reveal an invalid block. It might consider that revealing an invalid block is more valuable for the builder than revealing a valid one. And this can actually happen quite often. So this is a problem in block auctions that is kind of new. And this sort of problem has the feeling of the problems that we saw on an inclusion list, in that we need to start thinking again. So this is one of the reasons why I'm quite adamant that I want to have client developers, client core devs, to be implementing this right now, so that we can actually hash these problems now, and we're not caught off guard as we were on inclusion lists.
That's always good. Like, we can perhaps wait instead of pushing something which is not 100% ready. So I can totally understand the concern, and I really appreciate the decision of not including it in the Spectra upgrade. Hopefully, we'll see that in one of the future upgrades. I have a couple of more questions that I would like to quickly go over, and I know it's about time just to wrap it over. Do you have any speculation on DevNets for ePBS, and how far do you see ePBS from being implemented on the mainnet? An estimate in month and year should be fine.
What do you think, Terence? When are we having our first interop?
I think before DevCon is doable. That's definitely the goal that we have always aimed at just before DevCon. I cannot say for all the clients, but I know from the Prism side, I think we're pretty confident that we can have it before DevCon. In terms of mainnet, I definitely wish it's the fork after Petra. I don't have the timeline for that, but this is part of the Ethereum schedule and politics that is very hard to estimate.
A rough estimate is fine. And when we are saying that it would be after Petra, we could definitely expect 6 months down the line. I'm glad that we are making this discussion today and making this presentation available for people to follow this proposal even more and make this proposal ready before it is time for the network upgrade DevNet. And I really wish that we learn more about it, the interop session that generally client devs organize to check some proposals which are heavyweight to get in. Just before we wrap up, do you guys have any message for the community?
Please read the EIP and try to break it. Try to find bugs.
Very well. Short and sweet, but quite effective. Thank you. Thank you, Terence and Potuz, for sharing an overview of EIP-7732. It's been a pleasure having you on the show. For our listeners, if you want to dive deeper into ePBS and other Ethereum-related topics, check out breakout room meetings and follow today's guest for meeting summary on Twitter. Be sure to check out the latest discussion on Ethereum Magician Forum and the ETH Research website. If you have any questions, thoughts on this proposal or any other proposal, please leave a comment for us. And don't forget to like and subscribe to this special episode on PEEPanEIP. Subscribe to Ethereum Cat Herders, YouTube, and podcast to stay updated with the latest development in the Ethereum space. Until next time, keep watching, keep listening, and keep sharing your love with Ethereum Cat Herders. Cheers.